Hi everyone. So this video is to help you learn about parametric equations using Pythagorean identities. So this is going to be using trigonometry. We're going to be doing some stuff with decimals as well. So if you want to open decimals while we're working, that would be a good idea. Or at least know that you can do this on decimals. Be aware that that would be the best way to go about um, like checking your work as you go through it. Okay, so first of all, if you were given a set of parametric equations that are in terms of sine and cosine, the thing that you're going to want to do is solve for both sine of theta and cosine of theta so that you can substitute the expressions into your Pythagorean identity cosine squared plus sine squared equals 1. Okay, so, or whatever order you want to say it in, but you're going to solve for sine and cosine so you can substitute into this identity. So for example, we have this set of parametric equations right here. So you have x equals 4 cosine and y equals 4 sine. So you're going to solve both of these for cosine and sine. So divide by 4, divide by 4. And then you're going to take x over 4 and substitute it in for cosine and y over 4 and substitute it in for sine. So the identity here becomes this equation, x over 4 squared plus y over 4 squared equals 1. And if you actually square these pieces out and then multiply the denominator to the right side of the equation, you actually have an equation that is x squared plus y squared equals 16. And x squared plus y squared equals 16 is actually the equation of a circle. So now you can see that in this parametric form, you have a circle. And in this rectangular form, you also have a circle. So two versions of a circle. So if you see something that looks like this, and I want you noticing that the numbers in front of the cosine and the sine are the same. So when you see something like this, you have a circle. Okay, next. So now we're going to practice sketching this so you can see it, because it's not just that it graphs a circle. That's important to know, but it's also important to understand that it starts at a certain spot and ends at a certain spot. So I need to open up Desmos here. Oops, but I didn't have it ready, sorry. And I need to change this so it matches what we're going to be graphing. So we had, go back to the problem real quick. So the problem was 4 cosine, x equals 4 cosine, and y equals 4 sine. So x equals 4 cosine, y equals 4 sine. And we're going to graph this when t goes from 0 to 2 pi. So by the way, this is how you put a parametric equation in Desmos if you haven't already seen it. And I added a slider in here so that you can see it graphing in the correct order. Okay, so my slider is going to start at 0 and go until a is equal to, I believe, 1. So you can go all the way to 2 pi. So here we go. So notice that this circle started graphing at the point 4, 0, and then went counterclockwise. So this graphed from the point 4, 0 counterclockwise, and it took the whole entire 2 pi to do it. So I'm going to cut this, paste it over on our screen here, and write down what I just said so that hopefully you'll remember it and use that as you have to answer questions. So this equation started at the point 4, 0 and graphed in a counterclockwise direction. And I'm going to go back and grab the equation so that we remember what it was. So the equations had 4 cosine for x and 4 sine for y, and that's an important distinction as well. So 4 cosine and 4 sine in that order. Something different would happen if we switched them around. All right, which is actually what we're going to do with these two problems here. So it says find the rectangular equation whose parametric equations are given. Sketch each graph indicating its starting point and its orientation. So I'm going to do this one algebraically first, and then this one I'm going to do it with a graph first so you can see the difference, okay? All right, so remember what I told you is that you're supposed to solve for cosine and sine. So this is going to be x over 3 equals cosine of t. And then the other one is y over 2 equals sine of t. Okay, so that's your first step. Then the second step is to square both of these and substitute them into the trig identity cosine squared plus sine squared equals 1. So I'm going to go ahead and assume that you guys know how to square and substitute at the same time. So this is going to become x over 3 squared plus, I forgot my parentheses, y over 2 squared equals 1. Okay, so this is my rectangular form of the equation. I'm going to cut this. Okay, and then I want to make it look like something that hopefully you'll recognize when I actually retype it here. So if I square this, this is now, I'm going to do a couple steps here. X over 9, x squared over 9, excuse me, plus y squared over 4 equals 1. And then last year in honors algebra trig, you would have then simplified this problem, maybe, or you maybe would have left it like this. And I think you would have simplified it to this step because you would have had to do some division. And um, this here is actually the equation of an ellipse. Okay, so this is an ellipse here. And so if you remember how to graph an ellipse, you'll be able to get the whole graph on your grid, but we want to know that what the order it is that it's graphing in. And I want to point out to you that this has the cosine with the x and the sine with the y, just like the last problem we did. Okay, so it's has the same kind of situation here. I'm going to graph it on Desmos again so you can see. But I also want to tell you that if you were doing this by hand, something you could do would be to make a table of values to help you figure out the order. Of course, my table became huge here, so see if I can shrink this down. And the table of values, sometimes you don't even need a whole table. Sometimes you just need like the first couple points, and that'll help you know the order that you're going in. So if I put t's in the first column here, and then x in the second, and y in the third. Nope, don't want that. If I put 0, which is my starting point, in for t, so now we're doing cosine of 0, which is 1, times 3 gives us x is 3. And then 0 in for t here, sine of 0 is 0, times 2 is still 0. My first point is 0. So I've got my starting point, and then I'm going to put another value in to make sure I get the direction figured out. So if I do pi over 2, cosine of pi over 2 is 0, so x is 0. And sine of pi over 2 is 1, so y is 2. Okay, so you're starting over at 3, 0, and then going counterclockwise up to the point 0, 2. So I'm going to go ahead and, again, graph this on Desmos so you can see the order, just to make sure you're buying it. So this was 3 cosine, 2 sine, and so there's our ellipse. And if I start it, you can see it starts at 3, 0, goes up to 0, 2, and then goes back. Well, it's not supposed to do that, but goes back to 3, 0. So let me have it graph the whole thing. Pause. So started at this point and went in this direction. And this is really important that when you're graphing a parametric equation, you actually include the directional arrow. So if you were getting graded on this as like a class problem, you would want to make sure you included this starting point is here, and then the graph is going this way, okay? Now, if I had told you to only go from 0 to pi, then that would have only given you the upper half of this ellipse. So 0 to pi would have gone from 3, 0 to negative 3, 0. If I had told you to go from pi to 2 pi, then you would have only had the bottom half of the ellipse. So from 0 to pi would have been this upper part, sorry, and then from pi to 2 pi would have given you this bottom part, but still going in that same direction. All right, so let's look at the second one. First of all, it doesn't have the same numbers, but that's okay. And then the second of all, we've switched the sine and the cosine. So as I am doing a table of values here for you, I want you thinking about what do you think would happen when, or will happen when I change the sine and the cosine around like that. So let me just paste this table back over here. Okay. Oopsie. Get rid of these points, these values, and then we're going to check them. So at time equals 0, sine of 0 is 0. So that means x is 0. And cosine of 0 is 1. So that means y is 4. And then we're going to do pi over 2. So sine of pi over 2 is 1. So here x is 3. And cosine of pi over 2 is 0, so that means y is 0. This is kind of backwards the way we usually think of trig. Usually we think of x going with cosine and y going with sine, but this is actually the opposite direction. So my starting point is 0, 4, and then it's going down, so it's actually going clockwise. So it's starting at the top of the ellipse and going clockwise versus counterclockwise. So let me have Desmos graph this for us. So this was 3 sine, and then, oops, 4 cosine. And let's start this thing over so you can see it. So there it is at the top starting point, going around clockwise. Okay. And let me show you what I was saying before. If I only made this be from 0 to pi here, then this thing would still start at the top, but would only do this right half of the ellipse. And excuse me, if I went from pi to 2 pi, then it's going to, be interesting here. It's because of my time values. That's the problem. I'd have to change my time, but you would get the left half of the graph. Let's see if I can get it. That's so interesting because of the way I have the time set up, what it's giving me. So interesting. So this is the part of the graph that we're looking at here. All right, I hope that one makes sense. I'm going to come back over here and just type up a couple extra things that I said. So we said when we had x was equal to the sine values, this thing went clockwise. And when x is equal to the cosine values, then it goes counterclockwise. Okay. All right, next. So now we have another ellipse, and I've given you the graphs, and I want you to figure out which set of parametric equations you want to use to make this happen. I gave you some options already, but I added some additional pieces to it. So if this is the ellipse equation originally in rectangular, then if we only want it to graph half or a certain half of it, we need to figure out what we want to have x and y equal to. But so let's take a step back here. To get this going, this would be this would end up being x over 1 plus y over 3 squared. So I'm going to kind of walk backwards through this so you can see how this works. So that means that you've got really, like, this part could be equal to cosine and this part could be equal to sine, or vice versa. So you could say x over 1 equals cosine of t, And then you could say y over 3 is equal to sine of t. So that would be one option, which would mean x equals cosine and y equals 3 sine. Or you could say x over 1 equals sine of t, y over 3 is equal to cosine of t. And then you would have x equals sine and y equals 3 cosine. But you could also put some negatives in front of these things, and that would change also the direction that you're going in as well. Okay. But this is where the start comes from, where you break the original problem down. So it's something quantity squared. So x over something quantity squared, y over something quantity squared. Okay. So then we have to figure out which is the best choice. So this was the first set I told you. X is cosine, y is 3 sine. So this is the first one. And then here was the second one I was just talking about. And then we have these options that could put negatives in there. So you kind of have to pick which one you like depending on the direction, and then pick a starting point, which might mean you need to change the t values as well. So let's just start with this first one here. So this one here is starting at the point, this is a 1 here. This starting at the point 1, 0. It is then going counterclockwise up to the point 0, 3. So when I look at this, I think, well, I want it to start at 1, 0. That means my cosine has to be at the x, because x, that's how I'm going to get on the x-axis, is using cosine with the x. So right here, I'm looking at this one. If I put 0 in for time, I get 1 for x. If I put 0 in for time, I get 0 for y. If I go to pi over 2, then I'll get this point. So this is what I want for this first graph. And I'm only going to go from 0 to pi. So that one's pretty straightforward. Okay, the second one is starting at the point 0, 3 and is going still counterclockwise. Okay, so I need to get this point up here to be at 0, 3, which means I need y to give me 3 when I put whatever my starting time is going to be into the problem. Okay, so to have y equal to 3, obviously I've got to have it here with this, the y's. Let's see. Let's just see what happens if I start with this one. So if I put 0 in for time here, sine of 0 is 0. So that's not going to work. That's also a negative. But if I put pi over 2 in here, so if I do sine of pi over 2, I get sine of pi over 2 is 1. I would get negative 3. So that's closer. So maybe I jump to the next one and I say, oh, if I put pi over 2 in for this, that gives me 3 for my y. So that works for that part of it. And then I need to see, well, how am I going to get negative 1, comma 0 as my next point? So I need to go in this direction. So let's see what happens if I put pi. So I'm saying if I start off at pi over 2, if I put pi in for cosine here, pi in for cosine here is a negative 1. Well, this actually takes me back to a positive 1. So that's not going to work for me. That actually switches the direction. So I think for this problem, I still want this, but I want to start at pi over 2. So I want my graph to go from pi over 2 to 3 pi over 2, but still the same thing. Does that make sense? I hope it does. I'm asking a question to thin air that no one can answer. So please make sure if this is confusing to you, you let your teacher know. So let's just check one more time to make sure that you guys get that. So if I put pi over 2 in for cosine, I get 0. If I put pi over 2 in for sine, I get this 3. If I put pi in for cosine, I get negative 1. And pi in for sine, I get 0. If I put 3 pi over 2 in for cosine, I get 0. 3 pi over 2 in for sine gives me a -3. And then we'd stop. Okay, so the last problem here starts up again at 0, 3, and is now going clockwise direction and ending down here. So again, I'm only getting half of the ellipse. So if I want to start at 0, 3, I know that this one gave me 0, 3, but that took me, I had to do pi over 2, and that took me in the other direction. So if I just left this one and started at 0, so if I started this function at 0, I get 0, 3. And then if I went to pi over 2, so if I put pi over 2 in for this one, cosine of pi over 2 is 0. Sine, nope, that's not going to work either. So that's not going to work. I don't think that one's going to work. So let's go to another one of these that has a negative in some place here. So I'm still feeling like I like this option here. So let me drag that one over for a second. If I put 0 in for cosine here, I get -1. Nope, not going to work. If I put pi over 2 in for this one, cosine of pi over 2 is 0. So that works for the first point. If I put, let me write this down. So again, if I use pi over 2 as my starting point here, if I go to pi, so I use pi here, cosine of pi is -1 times another negative gives me a positive. So this problem works for this time interval. But what if I want to start at 0? So let's see if I can make it start at 0. So I want to start at 0 and get 0 as an answer. So that has to happen with one of these signs in for the x. So let's just say I take this. I'm just going to try it because then I should be able to determine by plugging values in if if this is going to work or I need to make something negative. So if I let time equals 0 here, so that's my goal. Sine of 0 is 0. So that gives me 0 for my x value. Cosine of 0 is 1. That gives me 3. So that actually works for the first point. So now let's try pi over 2. Sine of pi over 2 is 1. And that means I get the point 1 here. Cosine of pi over 2 is 0. I get it as well. Okay. So this equation works for the interval 0 to pi. And this equation works for the interval pi over 2 to 3 pi over 2. I did not tell you in the problem which one to choose, so you could have chosen either option. It would have been fine. It's a lot of me talking. I feel bad. I hope it makes sense. Please make sure you pause the video if you need to write stuff down and email your teacher if you have questions. All right, last thing in this video that's going to end up longer than I wanted it to be. We now have a circle and we want to figure out parametric equations for the circle, but it's being specific. So for this problem, you highlight here, the circle should only be graphed in the first and the fourth quadrant and should graph in the clockwise direction. Okay, so this is a circle with a radius of 5. And it should only be graphed in the first and the fourth quadrant. And it should go in the clockwise direction, which is actually not like that. I just went the wrong direction. Actually, this way. So this is very similar to the problem I just talked through with you. So first of all, if you rewrite this, it's going to end up as a couple of options. You could have x equals 5 cosine or x equals 5 sine. And then y is going to have the same values, right? So it'll be either sine or cosine, but it's going to have a 5 out front. So I want it to start up at the point 0, 5. So that means depending on what I want for my time will depend on if I want it to be cosine and sine in these places. So if I started off like this, I want my x value to be 0. And if I put 0 in for cosine here, that is not going to give me an x value of 0. So for this thing, I would have to start off with pi over 2. So cosine of pi over 2 is 0, and sine of pi over 2 is 1. So I get the point 0, 5. Now I want it to go this way, so I want to have the point 5, 0 next. So if I go to pi, because that would be the next thing in this window that I have, if I go to the pi value, cosine of pi is a -1, which means this actually gives me the point -5, which means I need to put a negative out front of this to make it go in the direction I want. Okay, so this is one option. The other option is to switch it so that the sine is with the x and the cosine is with the y. And then you should be able to start your time at 0 this way. So if I start at time equals 0, sine of 0 is 0, so that's your x value. Cosine of 0 is 1, so that gives you 5 as that starting point right there. Then if I use the next value, which would be pi over 2, sine of pi over 2 is 1. 5 times 1 is 5. So it goes in the correct direction, okay? So two options that I think are good. Part B says you only want the circle to be graphed in the third quadrant. So, oops, this part of it, we want it to go counterclockwise. Okay, so that means we want to start at -5, 0 and end at 0, 5. So if I want to start at -5, 0, in my head, I'm thinking of, well, if I make it be -5 cosine, um, and I start my time at 0, so cosine of 0 is 1 times a -5 gives you -5. Then I'm going to let my y be, well, I hope this is going to work, 5 sine of t. So I would want to use pi over 2. This would be my end bound. I'm going to say cosine of pi over 2 is 0. Sine of pi over 2 is 1 times 5 gives us this point here. So this one works as well. All right, I hope this all makes sense. I know this is kind of a long video. Please email your teacher if you have any questions.